they were doing radar research back in World War II. They had one of the guys left his sandwich on the table. You guys heard this story? Okay, so anyway, so I won't go over that. So it's all about like harmonics. So it's all about harmonics. So if I have a wave pattern like that, we know that's the frequency that water vibrates at. Then if I increase or add to that wave another wave that's the same, if I have a wave generator, then I create a bigger wave. And the bigger the amplitude, the more power. So the more power, the more it vibrates. Now, that's what's interesting about water when it comes to cooking, and using a mechanism like a microwave. Although with freezing, it's entirely different. There is no detractor, that's going to cause that. Although no, probably not. So I just had a thought, but it's okay. There's a never mind. But it's so we don't we can't really do that with water to get it cold. So the only way we can do that with is direct contact freezing, or same way we cook on a grill. We're taking something that's cold and dropping the temperature. Although what's important is that water is still in this shape. Now if it's in this shape, we know that it grows as a crystal. There's also what they call hydrogen bonding. So hydrogen bonding comes over with other water molecules, like this. Okay, and it forms, and the hydrogen bonds are very, very weak. To kind of give you an idea, what makes it fluid is the fact that those bonds are weak and they break and reform very easily. But as they get faster, they break even faster, and then they stop, actually forming, and they don't, and that's when they turn into gas. Okay, when they start to decrease in temperature, they slow down and they start to form again, the hydrogen bonding, and sooner or later, the bonds become so strong, the hydrogen bonding, that they become rigid. When they become rigid, that's a solid. Now, hydrogen bonds kind of work like this. They get in between each other. So this is, and so they, now this takes up less space than this does. And that's why water expands. Now, what it does is it starts to form, down at the molecular level, a structure that looks like this. Okay, and then it comes out like that. And so what does that start to look like? And I know this is rough drawing.
Snowflake.
Snowflake. So that's why snowflakes have the shape that they do. Although there's usually some particle in the center, and so you'll see some variation in the shape depending on what materials are in it. So for instance, with ice cream mix, if I take this ice cream mix and freeze it very slowly, they start to take on different shapes depending on what other things are in it. So for instance, like if I were to freeze the ice cream mix very, very slowly, I'm talking just like not even putting it in an ice cream machine, just throw it in the freezer and let it freeze, and then thaw it out. And then if I were to look at the water crystals, they start to have a really long shape to them, and they start to look like wood chips. And so they have a real flat, very long, elongated look to them. And that's what's really interesting, I think, about ice formation, is that the way the crystals form, if they're pure, they're going to turn out like that, like a water or a snowflake. But if they're not pure, if there's other things in it, like the milk solids or sugars or something like that, it's going to have a different shape. Now, it's anybody had ice cream that's had large water crystals? Mm-hmm. So nobody likes it. It's not very good. It's really grainy. I mean, I've had some where it's so bad that you can't even taste the flavor. The flavor's gone because all you can feel is the water crystals. Now, that happens because we have freezers that have defrost cycles. So those defrost cycles go up and down. Every time you refreeze, it freezes the ice cream slow, and those water crystals grow out of the ice cream mix. So what we want to do with ice cream is we want to freeze it fast. Now, the faster you freeze it, the smaller the water crystals. So the other thing, I don't know if you guys have noticed, I have, you know, but the if I take this and I heat it up and I heat it up into like a hot chocolate, it's going to be way too rich. It's like really, really rich. It's like, oh, I can't even drink it because it's so sweet, you know, and so rich. But yet this is like the lowest fat. This is ice milk, what they call ice milk, you know, back in the day. The government now calls it low fat because now that sounds better. So let's make low fat instead of ice milk. Nobody wants ice milk. Everyone wants it low fat. So it's all marketing, but you know that's a government term that they now changed everything to. So the and so this is the low fat. So if you heat that up, now the reason for that is because your tongue has, you know, receptors on it, and so if something's cold, it needs more of something to get the flavor across because those molecules aren't interacting as much. So like if I take rice milk, which I didn't drink, and if I just froze the rice, if I drink rice milk plain, it's fine, right? You know, you don't notice. It's like, all right, it's rice milk, or shada, same type of thing. So it's like if I take that and I freeze it, now it's like, ugh. There's no flavor to it, and it's because there's not as much interaction with the tongue. So it all depends on the temperature has a dependence on the flavor profile. So as a flavor, now we're going to get into some of that in a little bit when we start making some of the ice cream. But I'm going to do one gag that I do for the kids before we start talking more about ice cream, because I don't usually bring some of these flavors like bacon and Tabasco and apple and cinnamon. So we have cinnamon. We always have cinnamon, but we don't always have like applesauce. But we'll play around with a few things.
That's a pretty good combination, actually.
Before we move on, I want to freeze some marshmallows. So these are fresh and soft marshmallows. So I'll go ahead and grab some and just grab it and throw them in your mouth. Now watch what happens to your breath as it comes out, so you get that smoke coming out of your breath.
Top players on that, this is the restaurant. A couple $1,000 for that.
So it's not that was that interesting, but it was. I think it's, you know, it is pretty unique. If I let that, you know, come out, it'll just be. I mean, these are nice and soft and chewy, but when you get them frozen, they bring out a different texture. I think it's. Now, somebody made the comment before we started about whether this is how Dippin' Dots is done. Some of the different things you can do with nitrogen as far as the texture. Now, for instance, one thing we've learned is that the way Dippin' Dots is made is they take a vat of nitrogen, a big vat of it, and they take cream, they put it over a screen, and it drips into the nitrogen. It goes to the bottom, it's got kind of a conical shape down at the bottom, it's got an auger, and they auger it out, and it comes out in the bag. Now, if you use a KitchenAid, which is the most common way that I've found most people use liquid nitrogen to make ice cream, it comes out very whipped, but you've got some tines that are moving in there, and so you can only get it really as hard as the tines can move. Once the tines can't move anymore, you can't get any harder. It's got to have a fluid nature. So the way I look at it is that things have a fluid nature. Ice cream has to have a fluid nature. When it comes out of the machines at the plant, and it comes into the tub, it kind of, I don't know if you guys have ever seen it, but it kind of comes in and plops down, and it's very, very fluid. It's more fluid than soft serve. So it comes in there, it plops down, and they vibrate it kind of like concrete to get all the air out. They put the top on and stick it in the cabinet to freeze. Now, when you make ice cream, say Cold Stone, for instance, what they do is they take it, they put it in that machine, it comes out, it goes in the bins, probably a tray like this, something. Anyway, you know what I'm talking about. And then they put it in some kind of blast freezer, and they freeze it really hard for 8 hours. Bring it out of there. Now you can't serve it at 40 below, so so because they can't serve it at 40 below, then they put it in a storage cabinet for another 10 hours. To bring it up to 15 below, then they can put it on the table to serve. Well, it takes a lot of time. Again, it has to have a fluid nature. Typically for ice cream, what I consider is that we're the first ice cream shop to not have a fluid nature when it freezes. Now, what I mean by that is that I put the nitrogen on top, and usually most people, when they put nitrogen, even when they do it like us, I'm going to tell you something that when they put it in, they put a little bit in at a time, and they keep on putting it, trying to drop the temperature. And so what I'm going to tell you is everybody else does wrong. I'm going to tell you I'm not going to tell you what I do right. Okay? So what they do is they tend to stir. The normal, I'm just curious, okay, culinary people of the world, tell me your opinion. I'm just kidding, but it's, when I say stir, what does that usually, would that typically mean from the center or from the outside?
Folding is from the outside.
Yeah, okay, great. That's exactly what I wanted to hear. So most people stir, okay? Most people stir, so they put a little bit in. Now, if you put a little bit of nitrogen in to the cream, it's not going to cover the entire surface. And when you stir, what that does is it whips it out to the outside, and the first thing it comes to, it sticks to. So you end up with a bunch of hard crust on the outside and liquid still in the center. And each time you do that, it keeps on repeating. And every time you do that, then you end up with more crust and more liquid in the center, or less liquid in the center, but it's always going to have some liquid in the center. So at the bottom of that, there's some liquid, and it's white. And what is white that comes out of my breath?
The CO2.
Carbon dioxide. So we have a pretty good idea that was carbon dioxide inside there, just because of the fact that it was white. Now, so you can get different textures depending on how you use it. Agitation. If you use the KitchenAid, it gets really airy when you use nitrogen. It's more dense with the Dippin' Dots method. Our method, we don't whip it, so there's not air whipped into it, and so it's more dense. And we don't really, even though it looks like we're agitating, there's not really agitation because it's instantly freezing. So now, what I wanted to do as far as talking about flavors, we're going to do some of these interesting flavors. And the reason, oh shoot, it's all right. Oh, there it is. We're going to do maple bacon. Now, I want you to notice when we make it, I want you to notice as when you taste it, so let's make a good portion of it. I want you to notice when you taste it that there's kind of a Willy Wonka, I call it a Willy Wonka effect, because it tastes differently throughout the life cycle inside the mouth.
first, gets like snow first?
No. I haven't been able to find any good source of mount first. At least not consistent. They're not in season very often.
I'm sure Calvin's only two times a year.
It's okay. I also like another opinion. I want somebody to watch the method that I'm doing, and I want a definition of whether I'm folding. I know I'm not stirring because I'd be this from the center, but am I folding?
No.
No, I'm not. So that's my opinion. I'm not folding. We've actually filed for a patent.
We call it chugging, because we do that when you're doing eggs, chugging.
Chugging. Oh, never heard that term.
That's a Leslie.
Huh?
That's a Leslie term for chef.
But is it a culinary term or is it just a...
I've heard other chefs use it before, so.
We've had the thing that we use the word fold, and we knew what I meant by that was not fold in the culinary aspect. I meant fold like a piece of paper, because it creates a sheet. Yeah, sure. Yeah, that's fold like a piece of paper. So the where there was an article that said fold like egg whites, and I knew he was in error, and we do it differently than this article talked about. But the
Thank you.
Oh, but I didn't get a spoon.
But because this article, he was, and I met the guy, and he's the guy that founded Mathematica, and so he's a really brainiac, doesn't know anything about cooking. And I said, why do you use the word fold? And he said, I wanted to show that I knew something about cooking. He says that was it. It was just kind of, he says it was a joke. He says it was a total joke in the fact that he knew nothing about cooking and used a cooking term. Because he used the word, he also said, pour in the syrup of liquid nitrogen. I'm like, syrup? It's not a syrup, first of all. Anyway, it was okay, I'm gonna would not consider nitrogen to be a syrup. How many more we need?
Here's one, let's see, I need 1, 2,
I'm just trying, I want to get under the apple. Tabasco?
8. You need 8 more?
Okay.
Do you guys want to, you share it? Okay.
Yeah, I'm gonna sure.
Okay.
I'll make sure to lift my spoon first. Since I have to leave to another obligation, just make sure that whoever is elected to this board, that you are committed of taking this club and making it a real functioning club. Assisting Stephanie, because Stephanie's really, she's got a lot going on. So just please make sure that you are willing to put in the time. And thanks for coming.
take some applesauce. What's that? So what do you think? Is that
Delicious. Yeah.
so? It comes off with almost when it's cold. It comes off almost like a nut.
Yeah.
Like almost. In fact, I've handed it to people and say, "Well, that's an almond."
Yeah, finish it
They
up.
go,
I just want to taste
"No, now it's
Still room for the apple.
anyway."
So do I.
So it changes.
Yeah,
It
the bacon
changes
flavor doesn't
dynamic.
really come in until the end.
Yeah, exactly. And you'll get the same.
Bacon.
You'll get the same thing with the Tabasco. The Tabasco, well, you'll taste the apple first, and then you'll taste the Tabasco, and at the end, we'll put a fair amount of apple in there. Hopefully, the apple comes across. I should have going to get an apple flavoring, but or some pie flavoring, but
I like it. The sweet, salty.
Salt doesn't show up.
Put
Yeah,
some
exactly.
cinnamon in.
Oh, I'm good.
And we probably better put some caramel.
Wow.
Round out that flavor a little bit.
Just a little bit, though, right?
Just a little bit.
Get
And
you some brownie points.
the good stuff. And put a few shakes in there. We'll spice it up. Not a little more. The, now, I put a little more Tabasco than I usually put in. We'll see how it
It's all right, I
comes across. Yeah, we'll just do that.
Yeah, just a little bit, you know, just to be
Do the
safe.
larger batches, they keep your hands pretty cold. But it, in the store, we're doing single servings. We're just doing, our kit is about 4 ounces, so a little bit bigger than that, the cream we put in. Ends up about 6 ounces of finished product. But it doesn't really come close to your skin or your hands. So the bowls are big enough that they don't really, you don't get that real cold feel.
With my luck, they pop in my shoe and
Yeah. Okay, so let's give this a shot. Maybe I should try it first before I.
Whatever, I'm totally willing to do it. Put it down there.
I'm a spicy person. I like spice. I like a lot of spice.
We're all chef warriors. We're used to being guinea pigs.
Huh?
Yeah, chef warriors.
Does everybody still have their phone?
Oh, yeah, that's good.
Good?
Definitely taste the apple. I didn't put too much. Yeah, you can. That's great. See, that'll get the experience that I'm trying to get.
Turn off the back this now.
I almost didn't think I put enough in, you know, Tabasco. And then it was like, oh yeah, okay, there it is. That's what I'm trying to get at, is that change in flavor throughout. And I think when it comes to molecular gastronomy or food in general, it should be an experience. I think that's what you guys are all looking for. And so that's what I'm trying to do here for you guys, is to really come up with something. We don't do this in the store. You know,
You mean your apple Tabasco wouldn't sell very well?
When this is Utah, you try and sell.
I had, you know, where we came up with it is we had a customer ask for it. And I said, yeah, we can do that. I had some apple and I had some Tabasco and
Nice.
so he said that at BYU they did it one time as a special, you know, like limited time flavor. And I was like, he says he's never seen it since. He just loved it. But that's the advantage of our concept, is when it's made to order, you can do a lot of things you can't do, you know, by machinery. For instance, I really like mint and lime. Now, what is mint and lime?
Mojito.
Yeah, exactly. So it's but I like mint and lime. I like mint and amaretto. Mint and amaretto tastes like a pistachio. People always used to have, my favorite that I always tell people that I would like was black raspberry coconut with berries, because I like the smoothness of the coconut and I like the tartness of the berries.
Really that spicy, guys?
No, it's really not. I just got like a chunk of Tabasco there.
Oh, did you get a little bit? Woo!
Yeah.
Yeah. But it
Cinnamony.
it's interesting though, because
that
it
is
doesn't really taste
awesome.
like Tabasco. It just kind of tastes like
That is awesome.
hot cinnamon.
Yeah.
And it's
Well, the heat kicks in at the end.
yeah. Oh, she's just barely getting it. Oh, great. So see, I just think that's so interesting how we came up with these. We served these two flavors at a convention this last year, and they said we want something really unique, something you wouldn't have anywhere else. And so it was a textbook convention.
Has everybody gotten one? Who's not gotten one? Who have I missed? I think I got it. I'll run over to the teacher next door.
Yeah.
Gotta let it melt all the way to the mouth. Actually, I was a cheesemonger for a year. Cheese is very similar. The flavor profile changes with the temperature change.
Yeah. So
Apple, caramel, cinnamon, Tabasco.
so anyway, that's so if I take
Really, how would that work with alcohol?
How's it work with alcohol?
it's just fine.
It's fine.
We've done